Hello, everyone. Thank you for joining us for today's webinar. Today, we will be discussing the exciting possibilities associated with integrating performance data and digital twin models into the mine planning process. By way of introduction, my name is Jesse Oldham, Product Market Manager at Maptek. Maptek is a global provider of innovative software, hardware, and services for mining companies. Maptek has deployed our technology solutions at thousands of sites across the globe, where we've been helping to extend the capability of the mining industry while maintaining the key tenets of safety, productivity, and profitability. Joining me today is fellow mining engineer Dr. Penny Stewart, CEO of PETRA. PETRA is a leading provider of machine learning and optimization solutions to the global mining industry. And PETRA's suite of highly scalable solutions are successfully deployed by mining companies around the world. Maxta digital twin models for value chain optimization consume production and processing data. These models predict and simulate plant performance using machine learning, and they have been proven for applications such as geometallurgical prediction, drill and blast simulation, as well as process control simulation and optimization. Maxta machine learning models are readily deployed across the value chain from mine planning through to advanced process control. In today's webinar, we will outline what exactly is a digital twin model, and we'll look at a case study of how it was applied, as well as do a live demo of the integration between Vulcan and the Maxta model. In the case study, Penny will outline how this integrated approach was successfully deployed to improve gold recovery at Penn Austin Banhazai gold-silver operation in northern Laos. As a reminder, you can enter your questions into the questions panel on the GoToWebinar interface at any time during this session, and we'll answer as many questions as we can at the end, time permitting. Also, this session is being recorded, so you'll be able to watch it again in full later, and registrants will receive a notification when that is available. So earlier this year, Maptek and PETRA formed a partnership to solve true integration of mine production data with geological models and mine design. And this partnership leverages Maptek's expertise around ore body knowledge and mine planning with PETRA's advanced predictive and machine learning technologies to deepen the understanding of impacts on mine and processing performance. The Maxta digital twin, which is the focus of today's session, is ideal for targeting operational KPIs such as ore recovery, blast optimization, and more. And the result for miners is that planning is then based on better information. This in turn makes the digital twin models more relevant by virtue of their connection to geological models and mine design. So I'll now turn it over to Penny to discuss a little bit about this case study.
Yeah, thank you, Jesse. The best way to illustrate how to integrate the mine planning across the value chain is, I think, by a case study. And this case study is from Penn Austin Banhazai mine in Laos. Banhazai was experiencing frequent episodes of poor gold recovery due to high gold content in their tails. And whilst they did have a high level knowledge, like retrospectively, of where some of that low recovery ore was coming from, they weren't able to identify the geology associated with that problem. So this meant that they weren't able to predict where the low recovery was going to come from in the future, like looking forward for purposes of mine planning. They conducted extensive geometallical testing, but it was unable to identify the problem ore, and the mine continued to experience periods of less than 50% recovery. So this is when we started speaking to Penn Austin to see if our Maxta digital twin could help solve this problem. But look, before I do dive into the solution side of today's presentation, I think this is a good time to just stop and explain what we mean here when we're talking about digital twin. I'm sure that some of you have heard it in different contexts, so I'm going to just pause now and give a bit of a definition. So today, when we're speaking about digital twin in this context, we're talking about the integration of artificial intelligence, machine learning, and software analytics with the data to create a living digital simulation model. So it's the digital twin model that we're talking about today. Digital twin models can be used for two main purposes. There's the prediction, which is what will be in this case study. We're looking at a prediction application. we can also use them for the simulation. And I'll just give you some examples. So in the case of Maxta digital twins feeding back into mine planning, the plant performance data, this can provide far more accurate predictions for mine planning. And more accurate performance predictions means that as mining engineers, we're able to close the gap between what we plan to do and what actually happens across the value chain. So that's the prediction application. In addition to prediction, Maxta simulation enables us to ask questions of the data. For example, a drill and blast engineer can ask, how much extra SAG mill throughput could I expect if I increase the powder factor by, say, 0.2? And the planning engineers can ask questions like, what effect will this week's mine schedule have on plant throughput and recovery? So now let's go back to the Panasai case study to see how Maxta builds the digital twin of the mine value chain. So I'm sure some of you are, technical people here today will be interested in how is this actually done, the how part. Panasai is an open pit gold silver mining operation and has been in continuous production since 2012. The mine has produced 0.65 million ounces of gold and 4.7 million ounces of silver. Basically, Maxta builds the digital twin by virtually remining the block model. And we do this by using the historical fleet management data. So we will often, in the case of Panasai, Maxta ore tracking virtually rewind 2 years of historical data. That means every bucket, every truck over those 2 years has been tracked through to the plant. And this was a 10 million tonne an annum operation and had a total of 5.12 gigabytes of data. That means that Maxta has tracked the ore through to the processing plant using the fleet management data, and we also use virtual stockpiling. So that means we're building a virtual model of the stockpile to track the ore through that stockpile, and that includes not just the coarse ore stockpile, but also virtual models of the blended stockpiles as well. This is all important because that tracking process enables us to take the spatial data from the geology and turn it into and integrate it with the plant time series data. So we can join it with the throughput and the recovery with the ore characteristics arriving at the plant. Maxta software then uses this integrated data to produce the digital twin model. There are 4 main types of Maxta digital twin models. There's the Geometallic prediction model, which we're talking about in this case study, but there's also drill and blast simulation and optimization, mine planning and optimization application, and process control optimization in the plant. I'll talk a little bit about the drill and blast ones later in the presentation. When we deploy Maxta digital twin models back into the block model, this provides a continuously updating geometallurgical predictions on a block-by-block basis. So this means that each block has its own calculated predicted, in this case, recovery or throughput. So just for clarification, the Maxta digital twin models are machine learning models, and they're built using tens to hundreds of millions of tonnes of ore. So whilst the Panasai case study is in fact one of our very small case studies, we have applied this same approach onto the big iron ore mines of Western Australia, and where they're looking at hundreds of millions of tonnes of ore per year. But a bit later, I will show you the geological inputs for the Panasai Maxta machine learning models, because I'm sure some of the geos who are joining us today would be interested in that side of things. This is a very different approach to the traditional geometallurgical testing conducted on small hand-sized samples. So those type of geomet models are based on very limited percentage of the ore body. In the case of the processing plant digital twin models, the digital twin model updates and optimizes in near time. So that is a truly real-time twinned model. But in the case of the mine, the Maxta digital twin models are updated whenever the block model is updated. And these predictions are added to the block model of various formats by uploading to our highly secure Maxta web application. This means that when you do a block model update, for example, updating for grade control, you can upload that then to Maxta, and then it'll send you back all the updated predictions. But the purpose of this webinar is to demonstrate how the block models can be uploaded to Maxta directly from Vulcan, rather than needing to go outside of the mine planning environment. This is actually a really good point for me now to hand over to Jesse, who will demonstrate that Maxta integration with Vulcan.
Great. So for the this demo portion, we're going to jump over to Vulcan. And here in Vulcan, I have all of my geologic information, be it in surfaces and solids, as well as here in my block model. So here I've got a couple different block models. Perhaps this is a situation where I've got a new model, either based on updated drilling or new grade control model. But I have this new model with updated grade values, and I want to send that up to get the updated predictions and use those for mine planning and scheduling and whatnot. And so what I'm going to do is launch the PETRA portal, and in this case, this is done through a script to access the secure portal. I've embedded this in the workbench here so that I can, the workflow wise, it's very easy for me. And you can see this launches up the PETRA portal. I'll put in my credentials. And in addition to putting in my credentials, I'm also required to put in authentication. So this supports two-factor authentication. So put in my authentication code, and it says I've been authenticated as genuine user. So we'll talk a little bit more about the security here in just a minute as this is running. But now that I've been authenticated and I have access to the portal, I can come up here to the services. And in this case, I'm going to upload my block model. So click on that, and I can simply choose a block model file direct from this interface. Select the file and upload. So while this is uploading, a couple of things. So I have my BMF file in Vulcan. With this integration, no import or export is necessary, so I'm able to do that directly. This model in particular is around 500 megabyte, but it compresses down to about 10 meg. So you'll see that as part of what it's doing here is it's compressing that block model, and it's going to start sending that up to PETRA to get the updated predictions. And I'm running this from the States, but this particular model is hosted in Australia. So you'll notice it'll take a couple of minutes, but it's moving pretty quick actually. If that's hosted within your own region, it'd be much quicker. So as I mentioned, we are sending up the new block model, the updated block model with the new values up. It is going to retrieve the updated predictions from the Maxta model and then send that back. In this case, we're actually looking at two different models, one for SAG mill throughput and another one for tailings. So we've done it all in one go here. We didn't need to do it multiple times. I've sent up the model, and then as you can see, it's now completed. I've received back two updated variables for the SAG predictions as well as the tailings predictions. So as I mentioned, this is something where a user can upload the block model to be updated whenever there's a new model based on new drilling or other information, as well as when they are updating schedules or plans to be able to incorporate these variables into the schedule. So if I take a look now at my block model, you'll see I have these variables, tailing predictions and SAG predictions. Now, these can be viewed here in the block model itself. So all of these values are populated, and I can use these in my scheduling process for targeting or whatever else I may need to do with the SAG throughput or tailings in this case to improve the results of my mine planning. So Penny, in this case, what was the result of the deployment of this integration for Penn Austin?
Yes, you can see here just how Penn Austin is using this block model predictions. So this is looking forward. This is a life of mine shell of the pit, and it's showing how they've used the ability to forward predict to identify regions of the pit in the future where they can expect to encounter this problem. And this is really helping them now because they have a much more realistic way to predict where this high tails grade material is coming from, and they're using it now for both their shorter term planning and also for their life of mine, which you can see here. This slide comes from the presentation that James Carpenter gave at the Complex Ore Bodies Conference in Brisbane last year. Right, so at this point, I think it's worth mentioning the time it took to undertake this project. From the time we received the data, the total time from receiving the data to deploying the machine learning models into the block model was only 8 weeks. And this, I just want to acknowledge that this fast turnaround was made possible by the high levels of engagement from both the site personnel and also from the people in Penn Austin head office here in Brisbane. It's really good when you get that high levels of engagement from site and the great relationship with the head office. Moving on now, I did promise earlier that I would share with you the geology that goes into the Maxta digital twin models. And what you can see here is we've got 30 of the geological variables in the model. And as you can see, the Maxta model for tailings prediction has a range of inputs, including the geochemistry. There's some lithology, as well as, and this might be surprising to some, the rock mass characterization, such as fracture frequency and RQD. So what this is saying is that sometimes when it comes to understanding the performance of the geology downstream, there's a lot of complexity going on. And this complexity is able to be explained because we are able to access so much of that geological rich knowledge that is in the block model. I think this is a really good point now to move forward for Jesse to explain to you how you get started.
Yeah, so you saw how easy it was workflow-wise for an end user to be able to send up an updated model and receive predictions, and then they're able to use that in their process and their scheduling needs. But there's I'm sure a lot of things happening in the background first in order for that to happen. So Penny, what are the things that a site would need in order to get started with a Maxta digital twin model?
Yeah, so in order to build a Maxta digital twin model, we would need to undertake a period of data integration, and that would involve collecting information on the downstream process that you're trying to predict, as well as the geological block model and the fleet management data. That period of time would typically take, say, for a very direct tip operation with no stockpile, like no blended stockpiling, that might only take 8 weeks. But when you're looking at a more complex operation with multiple blended stockpiles and blended stockpiles before the crusher, that is, and then say a complex coarse ore stockpile configuration, then it could be up to 14 weeks. So it's somewhere between that 8 and 14 weeks period to integrate the data into Maxta. You also would need to, quite separately from Vulcan, we have a Maxta license as well. So you would need to obtain in order to access the web application.
Great. And on the Vulcan side of things, in terms of licensing, is you have any of the modeler configurations that include the ability to edit and access the block model, GeoModeler, open cut mine modeler configurations, etc. Those type of licenses you would need in order to access this. And then you saw the simple scripting components in order to access the PETRA portal, and that can be integrated into the workbench or into your workflows, into the Maptek workbench workflows as well. Now, Penny, earlier you mentioned there were some additional applications of this beyond the geometallurgical. Could you touch on those?
Yeah, that's right. So we've seen the geometallurgy example for Penn Austin, but I'd also, just because of the audience we have probably on the line from some mining engineers probably, I thought it would be worth also showing an example for drill and blast application. So what you can see here is the drill and blast application for Maxta. So what you can do is we built the digital twin model using the historical geology and the historical drill and blast design data, and then also the downstream performance. So in this particular case, it's been set up for a loading dig rate and for 2 crushers. So that what that means is when the drill and blast engineer selects a polygon from the drill and blast, they're under the blast ID, then they upload the block model associated with that polygon. So it's the blocks that we sit within that polygon. The Maxta model then runs on those blocks and estimates the dig rate and the crusher throughputs for the base case. Then once you've got that base case, you can then do the what if simulation experiments that I referred to earlier. So if you remember, the Maxta digital twin model has 2 applications. One is the prediction and the other is the simulation. This is the simulation side of it. So this is where you can do virtual experiments and see what effect you will have downstream. So you could change the burden, the spacing, the explosive density, and then see what effect that has. The limitation is on the historical data. So if you can query and make what if questions about any of the drill and blast designs that you will have used historically at that mine. Another application is very similar to the application with Geomet, but this is with the optimization using evolution. So our next project with Maptek is to integrate the predictions from Maxta into optimization, and that optimization in evolution can be the life of mine optimization or more of the shorter term optimization that you can do with evolution. So what that means is that evolution is using real data from operations to optimize the mine plan, whether it be life of mine or short-term planning. And this obviously means that the assumptions that go into your life of mine planning are far more accurate because they're feeding back the real performance of the mine. So we've been calling this dynamic optimization. So thank you, Jesse. They were the next steps, so we can move on now.
Excellent. Thanks, Penny. And we do have a few minutes for questions. We do have a couple that have come in so far that we'll get to, but just as a reminder, if you do have any questions that have popped up over the course of this session, feel free to type them over in the GoToWebinar panel. We'll go ahead and get started on these couple that have come in so far. So Penny, how often are the Maxta digital twin models updated?
We would typically see mining companies update it once a year. There might be a need to do that more often. So if you're starting in a new pit area and you want to capture that history, or if you're doing a new cutback and you believe it's in a different geological domain, then in that case you would consider rebuilding the Maxta digital twin model more often, and that would typically involve us doing several weeks of work on our side to retrain that model. If you do have your data available in another source, it is possible to automate the retraining, which is what we do in the processing plant. So in the processing plant, we don't need to do this offline. It's all dynamically updating. So the retraining process occurs automatically in a processing plant because that data is available to the model. But where it's not online, in that case, we do have to do the retrain offline, and it takes us a few weeks.
Okay, excellent. So a site would maybe be looking at updating their actual Maxta model at that frequency you mentioned, and then in terms of using that model, that can be at whatever frequency they have for updating their block models, whether with new drilling or as they're updating their schedules. Is that right?
Yes, that's right.
Excellent. All right, next question. What machine learning models did you use for the prediction?
Yeah, look, unfortunately, it would be we won't be able to go into that level of detail. It's a proprietary software, so unfortunately, I'm not going to be able to answer that one today. But I can tell you that we don't just use one type of machine learning model, that we use a range of different models for different applications, and that there is no one simple solution here.
Okay. So next question, what data is required to account for the stockpile movement to link the spatial data in the block model to the actual processing time/date of that block?
Okay, so what we use there is the fleet management data, and in particularly we use the GPS data. Now we have done this with and without high precision GPS. So ideally, if you've got high precision GPS, we can give more granularity on the location of that ore within the stockpile, but we don't have to have high precision GPS, and we can build good model, we've been able to build really good models without that high precision GPS. We effectively are tracking where the dump locations are within a stockpile, and then we have a way of aggregating that data so that we estimate within different regions of that stockpile what the tons weighted average is at each of those locations, so that then when the rehandle fleet that might be moving that ore to the crusher, when they go to rehandle it, we know what the attributes are on a tons weighted average basis.
Excellent. Well, that's all we have for today. So Penny, thank you again so much for joining us today, and thank you to all of our attendees. We hope we're sending you away with a clear idea of the potential associated with integrating the digital twin models into your operation. This closing slide here has our email addresses, so please don't hesitate to get in touch with us either at Petra or Maptek to discuss more about this integration and discuss how you can start gaining the benefits of a truly integrated mine planning. So thank you, everyone.